In this video, I'm going to do a quick rundown on ionic versus covalent compounds, meaning I'm going to talk about how to differentiate between the two, how to name from a given formula, and also how to write a formula from a given name. To start out, let's talk about the basic differences between ionic and covalent compounds. An ionic compound is made up of a metal and a nonmetal. Remember metals, if you remember the periodic table, that's terribly drawn. We have the staircase. Anything to the left of that staircase is going to be a metal, and anything to the right of that staircase is going to be a nonmetal. So it's going to be an element from this region of the periodic table bonded to an element in this region of the periodic table. Whereas for a covalent bond, that is going to be two nonmetals bonded together. So again, if we draw the periodic table, and we have our staircase, it's going to be two elements from this region of your periodic table. The next big difference that you should remember from our chemical bond unit is that the ionic compounds is going to be a transfer of electrons, whereas covalent is a sharing of electrons. And this can help you to understand why we crisscross to determine the subscripts in an ionic compound and why we don't in a covalent. Okay. The only other thing that you should maybe know is that ionic compounds are the only compound that's going to contain a polyatomic. And to make that clear, I'm going to add the word can. They can contain a polyatomic. They don't have to, but anytime you see a polyatomic, it's automatically going to be an ionic compound. So those are the major differences between the two types of compounds. Now let's get into differentiating between the two when it comes to names and formulas. If we look at this compound given to us, NaCl, we can look at it and we can divide it into its two parts. We are going to have the first element and the second. The first element is either going to be a metal or a nonmetal. The second element is always going to be a nonmetal. So we're really just looking at this first element. If the first element is a metal, that means it is an ionic compound. So this one, NaCl, Na is in group 1. Therefore, that makes it a metal. It's also to the left of the staircase. So NaCl is going to be an ionic compound. If we look at this compound, MgCl2, or magnesium chloride, again, we can just look at the first part. Mg is magnesium. This is in group 2 on the periodic table, so we know that this is also a metal. Since there is a metal in the compound, that means that this is an ionic compound. If we take a look at copper oxide, copper is also to the left of the staircase. This is in the D block, also known as the transition metals, but it's still a metal, which means that this is also an ionic compound. This compound, the first element is nitrogen. If you look on your periodic table, nitrogen is found to the right of the staircase, making this a nonmetal. And remember I said the second element is always going to be a nonmetal in both cases. So we just need to look at this first element. We see that nitrogen is a nonmetal, which means that this is a covalent compound. If we look at this compound, again, the second element is always going to be a nonmetal. So we just look at the first element to determine what type of compound it is. We know that carbon is to the right of the staircase, making it a nonmetal. And if the first element is a nonmetal, then we know that this is a covalent compound. Let's do a little exercise. I've given you 4 different compounds. Please take a second to look at each of the 4 compounds and determine whether it is ionic or covalent based on the types of elements in each compound. This first one contains calcium. Calcium is in group 2, making it a metal, which means that calcium chloride would be an ionic compound. For the second one, carbon is a nonmetal. When we see a nonmetal as the first element, we can automatically know that this is a covalent compound. The third one, we see Fe, which is iron. That is a transition metal, which means that this is going to be an ionic compound. This one down here is tricky. You may notice that this is water, but hydrogen is the first element. Hydrogen acts as a nonmetal. It is going to be a part of the elements that are considered nonmetals. So therefore, water is covalent. All right, let's get into naming ionic compounds. So we should be able to determine whether or not a compound is ionic just by looking at that first element. If that first element is a metal, then you know it is ionic. But now let's look at how to name the compound once you've determined that it's ionic. What you are going to do, this is the general rule, is you are going to write the element name of the metal, just normal, like sodium or magnesium or calcium or iron. Then, to that, you are going to write the element name of the nonmetal, but you are going to replace the ending of that element name with IDE, meaning instead of, if we have chlorine as our nonmetal, instead of writing out chlorine, we are going to write out chloride. Okay? Now, let's do an example. Let's try this one. BeBr2. You know it's ionic because the beginning, Be, is beryllium, and that is a metal. So you automatically know this is ionic. So we need to write the element name of the metal. So we are going to write beryllium. And then we have the nonmetal bromine. So we're going to write the element name of the nonmetal, but with an IDE ending. So this is going to become beryllium bromide. So instead of writing bromine, we've replaced the ending with IDE. And that's how you name ionic compounds. Let's take a look at this example. Al2S3. Now with ionic compounds, these subscripts don't matter for the basic ionic compounds like I've been showing you. We're just worried about the elements themselves. So this one, we're going to write the element name of the metal. In this case, it is Al. We know that is aluminum. And then our nonmetal is sulfur. So we are going to put the element name of the nonmetal with an IDE ending. So this becomes sulfide. So Al2S3 becomes aluminum sulfide. And notice these subscripts don't make any difference in how I name the compound. So this is for basic ionic compounds. These don't matter. Let's say that we have the compound Ki. We look at the first element and we notice that potassium is in group 1, it is classified as a metal. So therefore, we automatically know that this is an ionic compound. To name it, we are going to write the element name of the metal. So we have potassium. And then we are going to write the element name of the nonmetal, which in this case is iodine. But instead of writing iodine, we're going to replace the ending with IDE. So it becomes iodide. So therefore, the name of Ki is going to be potassium iodide. Let's try 3 of them on our own. MgBr2, Li2O, SR3N2. Try going through this generic formula for naming ionic compounds and name these 3 compounds. Pause the video if you need to. So we notice that the first element in all of these compounds is a metal. Magnesium is in group 2, lithium is in group 1, strontium is in group 2. Those are all metals, so we can therefore classify them as ionic compounds. To start with MgBr2, we write the element name of the metal. So we write magnesium. And then we write the element name of the nonmetal. This is bromine, but with an IDE ending, so it becomes bromide. For the second one, we write the element name of the metal. In this case, we have lithium. Then we write the element name of the nonmetal, which in this case is oxygen, but replace the ending with IDE to make it oxide. Again, notice how these subscripts don't make any difference in how we name these compounds. For the last one, Sr, we write the element name, which is strontium. And then we write the element name of the nonmetal, which in this case is nitrogen, but with an IDE ending, making it nitride. And that is how you name basic ionic compounds. Now, let's focus on how to name covalent compounds. For covalent compounds, we are going to be using something called prefixes. So you should have a printout of these. That goes actually up to 10, but I'm just going to stick with 8 for this video. This column is the number of atoms of that element, and this column is going to be the associated prefix for that number of atoms. So for instance, if we were working with N2O4, we know this is covalent because nitrogen is a nonmetal, as is oxygen. So how we write this is we are going to write the name of the first nonmetal. So we are just going to write nitrogen. So this is very similar to how we did the ionic compounds. And then we're going to write the name of the other nonmetal, but with the IDE ending. So we are going to put oxide. Now, this looks exactly like the ionic compounds, but for covalent, we need to tell whoever is reading this compound name how many nitrogens and how many oxygens are in this compound. And this will make more sense when we go from name to formula. But if we have more than one of the first nonmetal, so in this case we have 2, that means you are going to put a prefix on that first element's name. So in this case, we have 2 nitrogen. We look up here at our table, we see 2 is, the prefix is di, so this becomes dinitrogen. And we always put a prefix on the second element. So I'm just going to make that note here. So on the first one, we only put a prefix if there's more than 1. You never put a prefix if there's only 1. For the second element, you always put a prefix. Always. No matter how many there are, it always gets a prefix. So in this case, we have 4 oxygens. So we look at our table here, we see that 4 is tetra. So we are going to have it be dinitrogen tetraoxide. So the foundation of this, the nitrogen oxide, is exactly the same way you named ionic compounds, but now for covalent, we are going to add prefixes to show how many of each element there are in the compound. Let's try another example. So here we have SF6. So to name this, let's start with the very basics. We are going to put the name of the first nonmetal, which is sulfur. And then we are going to write the name of the second nonmetal, which in this case is fluorine, but we're going to replace the ending with IDE to make it fluoride. So again, this is the exact same way that you named basic ionic compounds, but since we're working with covalent compounds, since this is a nonmetal, we need to put prefixes in front of both words. Now, we have to be careful because there is one instance where you don't put a prefix before a word, and we have that here. For the first nonmetal, you put a prefix if there is more than 1. You never put the prefix for 1 in front of the first name. So you never are going to put monosulfur. It's just sulfur. Then, for the second part of my name, you always put a prefix. So in this case, we have 6 fluorines. So we look at our table here, we see that 6 is hexa. So we put the prefix hexa in front of the fluoride. So this becomes sulfur hexafluoride. Again, no prefix is telling me that I have 1 single sulfur. Hexafluoride means there's 6 fluorines attached. Let's say that we have this compound, carbon and oxygen. We know this is covalent because carbon is a nonmetal. Whenever you have a nonmetal in the first position, you know it's covalent. Remember, nonmetals are to the right of the staircase on the periodic table. So to name this, we are going to write the element name of the first nonmetal, which in this case is carbon. And then we are going to write the name of the second nonmetal with the IDE ending. So this would become oxide. Now we need to put prefixes on it because it is covalent. You only put a prefix on the first element if there is more than 1. There's only 1, so we do not put a prefix on the carbon. You always put a prefix on the second element, no matter how many there are. We have 1 single oxygen, so we go to our table. 1, the prefix is mono. And I'm actually not going to put that extra O in just so that it sounds better. That's how it's done. So this becomes carbon monoxide. Remember, no prefix if there's 1, always a prefix. So let's try naming 3 different covalent compounds. We know each of these is covalent because the first element in each is a nonmetal. So why don't you take a second, maybe pause the video if you need to, and try naming each of these covalent compounds. So this first one here, again, we write the name of the first nonmetal, and we write the name of the second with the IDE ending, so that's oxide. I'm running out of room here. And then we go back and we put prefixes in. So since we have more than one of the first nonmetal, we are going to put a prefix. We have 2 phosphoruses, so we go to our table. The prefix for 2 is di, so this becomes diphosphorus, meaning we have 2 phosphoruses, which we do. Here, we always put a prefix on the second part of our naming. So we have 5 oxygen. The prefix for 5 is penta. So it becomes diphosphorus pentaoxide. 2 phosphoruses, 5 oxygens. The second one, we have a single carbon. So we're going to write carbon. And then we put the IDE ending on the second nonmetal, so this becomes bromide. And then we go back and we put our prefixes. 1 carbon, so if there's only one of the first nonmetal, we don't put a prefix at all. So it's just carbon. The second nonmetal, we always put a prefix, and we have 4 of them. So we look at our table, 4 is tetra. So this becomes carbon tetrabromide. Down here, we have nitrogen first. So we are going to just simply write nitrogen. And then we are going to write the name of the second nonmetal with the IDE ending, which is oxide. And then we go through and we put prefixes. So here we have 2 nitrogens. So since we have more than one of the first nonmetal, we are going to put a prefix. We see that 2 has the prefix di, so this becomes dinitrogen. And we only have a single oxygen, but we always put a prefix no matter what for the second nonmetal. So the prefix for 1 is mono. And again, we are going to double up on that vowel there to become dinitrogen monoxide. Okay, we are going to now focus on writing formulas for covalent compounds. So we are going to take the name for a covalent compound and turn it into a formula. Notice how I still am going to need this prefix chart. If you have these memorized, you might not need this, but I'm going to keep it here just in case. So we look at the first one, dihydrogen monoxide. The prefix that is attached to each part of this name is going to tell you how many of that element there are in the formula. There is no crisscrossing with covalent formulas. So dihydrogen is telling me that I have 2 hydrogens in my compound. Monoxide, the prefix mono is 1, oxide is oxygens, meaning that I have a single oxygen in my compound. When I put these together in a correct formula, H2O. Dihydrogen, 2 hydrogens, monoxide, 1 oxygen, H2O. Let's try the second one. Remember, the prefix is how many of that element there are in the compound. So trinitrogen, nitrogen is N, trinitrogen means there's 3 of them. Fluoride is F, fluorine. Hepta is telling me how many fluorines there are. Hepta is 7. When I put those together into a nice neat formula, N3F7. So it's really simple as long as you understand that the prefixes are telling you how many of that nonmetal you have in your formula. So this trinitrogen, this means that it is N3. Let's try two more. Carbon hexafluoride and carbon dioxide. This bottom one might sound familiar, but let's start with the top. So carbon, when you don't see a prefix on it, you know that there is just one. So no prefix on our carbon tells us that there is a single carbon. The prefix hexa here means 6. That is telling us how many fluorines there are in the compound. So fluorine is F, hexa means there's 6 of them, to be F6. When we put those together into a nice neat formula, carbon hexafluoride, CF6. This bottom one, same kind of deal. No prefix on the carbon is going to be one single carbon. Oxide is oxygen. The di is telling me that there's 2 of them. Again, there is no crisscrossing at all when you're writing covalent formulas. So this, put nice and neat into a compound, is CO2. The easiest way to tell by name if it is covalent is looking for these prefixes in the name. Don't just look at the first word of the name, because if you don't see a prefix here, that doesn't mean this isn't covalent. That just could mean that there's a single nonmetal. So always make sure you're looking for these prefixes to determine or help you to determine if it's covalent. Let's try 2 exercises. Why don't you try writing the formulas for both of these covalent compounds? Pause the video if you need to. So the first one, sulfur octaoxide, when you don't see a prefix on the first nonmetal or the first part of the name, you know that that means that there's only one. So sulfur we know is S. The lack of prefix before it is telling us that there is only one of them. Oxide is O. That's a terrible O. The octa before the oxide means that there's 8 oxygens, so this becomes O8. Putting this together nicely becomes SO8. Again, there is no crisscrossing. The second one, dinitrogen triiodide, nitrogen is N. The di before it is telling you how many of the nitrogens there are. Di means 2, so you should have N2. Iodide is iodine, which is I. Tri is telling you how many iodines there are. Tri means 3, so there's 3 iodines. Put those together to get N2I3. Now let's go on, and we are going to learn how to write formulas for ionic compounds. Remember that ionic compounds contain a metal and a nonmetal. There are some trends on the periodic table that you are going to need to know in order to write the formulas for ionic compounds. I have them written on a post-it note, but you can easily write them on your own periodic table. All the elements located in group 1 of the periodic table are going to form a +1 charge when they form ions. So when an element in group 1 gives up their electrons, like they would do when forming a compound, they are going to have a +1 charge. All elements in group 2 will have a +2 charge. We're going to skip the D block completely, that transition metal box. We're going to skip that and move all the way over to group 13. That is the group that has aluminum and boron in it. Those elements are going to form a +3 charge. We're going to skip group 14 because that's just beyond this video's scope. So we are going to skip that and go to group 15, We're now in the nonmetals. So all the elements in group 15 will form a -3 charge. All elements in group 16 will form a -2 charge. And all elements in group 17 will form a -1 charge. So if you need to take a second and write that on your periodic table, please do so. But those are going to be extremely important for writing the formulas. Now we are also going to use something called crisscross, which I'll explain in a second, but that is the terminology that I use, crisscross. It involves these charges here. So for example, if we start with this example, aluminum oxide, the first step is to write the symbols for both elements. So aluminum, you know, is Al, and oxide is O. Easy. The next step is following these patterns on the periodic table to figure out the charges on both elements. We can also call this the oxidation number. It's the possible charge that each element can form. So for instance, aluminum is in group 13. We know that those are going to have a +3 charge. So I just like to write it right above the symbol. This is not actually part of the formula, but we use it to figure out the formula. Oxygen is in group 16, and we know that it's going to form a -2 charge. So we write that above it. Now when we get to the crisscross, which is right now, it's exactly what it sounds like. We are going to crisscross. So we are going to take the charge above the aluminum, just the number. We don't actually take the positive and negative with us, just the number, and we are going to put it as a subscript on the other element. So the 3 above the aluminum goes as a subscript on the oxygen. Then we take the number above the oxygen, again leaving the negative behind, and we are going to crisscross that and put it as a subscript on the aluminum. Okay, so this becomes, if we clean it up, aluminum oxide is known as Al2O3, and that is the correct formula. So that is how you crisscross. Let's say that we take the example magnesium bromide. Again, the first step is to write the symbols for both. So magnesium is Mg, and bromine, or bromide, Br. The next step is to use our trends on the periodic table to figure out the charge for both elements. Magnesium is in group 2, so we know that it is going to have a +2 charge. And again, I just read it above. It's not actually a part of the formula, but we use it to get our formula. Bromine is in group 17, so I know that it is going to have a -1 charge to it. Then we crisscross. So I take the number above the magnesium, again leaving the plus and minus behind, and I am going to put it as a subscript on the other element. So I took the 2 above magnesium and I put it as a subscript on the bromine. Then I take the number above the bromine, again leaving that negative charge and just using the number, and I am going to put that as a subscript on the magnesium. But you guys should know that we don't write ones as subscripts, so really you don't put anything. If I were to clean this up here, the correct formula for magnesium bromide is MgBr2. Again, finding the different oxidation numbers or charges of each of these elements and then crisscrossing them to figure out the subscripts on each. That's how you write an ionic formula. There is one thing that you guys should know, and we're going to see it if we write the formula for sodium chloride. So let's start by writing the symbols for both sodium and chloride. Sodium is Na, chloride, you know, is Cl. When we look on the periodic table, we know that sodium is in group 1, so it's going to have a +1 charge, and chlorine is in group 17, giving it a -1 charge. When you see that these charges are equal and opposite, equal meaning they're the same number, and opposite meaning one is positive and one is negatively charged, they cancel out, so we don't have to put any subscripts, and this just becomes NaCl. We can see the same trend if we were to do, actually let me change that. Let's do calcium oxide. Calcium, you know, is Ca. Oxide or oxygen is O. Calcium can be found in group 2, which gives it a +2 charge. Oxygen is in group 16, which gives it a -2 charge. Again, these are equal and opposite. Equal because they're both 2's, opposite because one is a positive and one is a negative charge. When that is the case, they cancel out, leaving you with no subscripts and the formula CaO. So be very careful. You don't always have to crisscross. If the charges cancel each other out, then you don't need any subscripts at all. With that being said, if you were to crisscross and have this become Ca2O2, that is incorrect. This is telling me that I need 2 calcium atoms and 2 oxygen atoms to form 1 molecule of calcium oxide. That is not the case. So whenever you see subscripts that can be simplified, meaning I could simplify both of these by dividing them both by 2 to get 1s, you need to do that. You need to simplify them. Another example of something that needs to be simplified, and this will come up, Let's go ahead and try some practice problems. So I would like you to take a minute to write the formulas for strontium oxide and aluminum sulfide. Notice how both of these are ionic because they contain a metal. So if you need to pause the video, go for it. For strontium oxide, I'm going to start by writing the symbols for both elements. Strontium I know is Sr, and oxide or oxygen is O. The next step is to figure out the charges for both elements using this trend on the periodic table. Strontium can be found in group 2, meaning it's going to have a +2 charge. Oxygen is found in group 16, giving it a -2 charge. When we put these together, we can notice that these charges are equal and opposite, so they cancel out, leaving us with SrO. For aluminum sulfide, we're going to start by writing the symbols. So aluminum is Al, sulfide is S. Aluminum is in group 13, which means it's going to have a +3 charge. And sulfur is in group 16, giving it a -2 charge. These are not equal and opposite, so these are not going to cancel out, and we need to crisscross. So we are going to take this number above the aluminum, and we are going to put it as a subscript on the sulfur. And then we're going to take the number above the sulfur and put it as a subscript on the aluminum. To clean this up, you should have gotten Al2S3 as your correct formula for aluminum sulfide. And that's how you name basic ionic compounds.